Hello, dear students. This is Irfan, and you guys are watching Irfan Equation. Today, we're going to talk about another application of the derivatives, which we've been through in 3.3 before. The same application we use actually for instantaneous rate of change. So, if at any point on the graph, at any point during the movement of the body, if we want to find the instant rate of change, this is the very formula we've been using in 3.3 about the derivatives. We use the same formula here to find the instant rate of change. So another one, how do we find the average speed here? The speed here is distance divided by time. That speed is actually the absolute value of the velocity, and we will see how do we do it. Afterwards, okay, the second derivative of the function gives us acceleration, basically. And third derivative of the function gives us the jerk, which we are not talking about in this very part of the discussion. So let's move to the question. So in question number one, in the first six questions, they said find the body's displacement and average velocity for the given time. So we have to find the displacement and average velocity. So let's move to the notebook. Okay, the first question they're asking, they said find the body's displacement and average velocities. That's our first part. In the A part, we need to find body's displacement and average velocity. Okay, how do we find the displacement? The formula for displacement is change of the displacement equals to change in the last point, okay, which is 2 here, subtract the change of the initial point, which is 0. So let's find the function when we switch t with 2 here, which is 2 square minus 3 times 2 plus 2, negative sign, square bracket, then we be inside there. So it's going to be 0 square minus 3 times 0 plus 2, bracket close. So let's simplify it further. 4 minus 6 plus 2 minus, okay, 0 becomes 0. This will become 0, and we will left with plus 2 only. So let's write this here. That's plus 2. 4 plus 2 minus 6, they all cancelled out. We are left with minus 2 only. So minus 2 meter is actually the displacement of the body. That's how we do it. Simple as finding. Okay, in the second part of the discussion, they said find average velocity. Average velocity. So let's see how do we find the average velocity. Average velocity, we represent it with the letter VAV, and it equals to the change in the displacement divided by change in the time interval. All right, so change in the displacement that we already found out in the first part of the question, which is minus 2, and the change in the interval says it's changing from 0 to 2. So the change interval will be the final point minus the initial point, which is 2 minus 0. So let me write this, 2 minus 0 equals to minus 2 over 2. And finally, it's minus 1 meter per second. So average velocity of the movement of the body in the first part is minus 1 meter per second per second. Okay, B part. In the second part, they said find body's speed and acceleration. Remember, the speed is the absolute value of the velocity, so we have to find the absolute value. We have to find the velocity, then its absolute value, which is actually going to be the speed. And acceleration, second derivative of the function, so let's do it. All right, so first of all, absolute value of the speed at time t, that's the function, which equals to the absolute value of the velocity. And absolute value of the velocity, remember, the velocity is actually the first derivative. The first derivative of the function is velocity, second derivative is acceleration, and the third derivative is going to be the jerk. So we need to find this absolute value. No matter what, it is going to be positive always. Okay, so and this actually referred to as speed. All right. So let's take the first derivative of the function, and the function is this one. Let me copy this over here. It's t squared minus 3t plus 2. 3t squared minus 3t plus 2. All right, so velocity. Let's find the velocity first, which is the first derivative of the function. ds over dt equals to. So as we have this function over here, it's t squared. So after taking the derivation, it will be 2t minus 3, and the constant becomes 0. So 2t minus 3 is actually the velocity, and we need to take its absolute value. They said take the absolute value, find the absolute values, find the speed and acceleration at the endpoints. 0 and 2 are the endpoints. So let's find the speed at the endpoints now. All right, so to find the speed at endpoints, let's take v at t with its absolute value, which is actually 2t minus 3t, 2 into t 0 minus 3, that's the first endpoint. And this is 2 times 0, 0 is minus 3. Okay, minus 3. So absolute value makes it positive, so it's going to be 3 meter per second. Then absolute value of the velocity or the speed at endpoint. 2, so absolute value 2 into 2 minus 3 absolute value equals to 2 times 4, 4 minus 3 is 1, so it's going to be 1 meter per second. These are the values of the speed at the endpoints. Then they said that in the second part of the question, they said find the acceleration as well on the endpoints. And remember, the acceleration is actually the second derivative of the function. So for acceleration which actually equals to the second derivative of the function, so it's going to be dv over dt and d over dt, and the value of the function is 2t minus 3. We find the actually derivative of the velocity, which is 2t minus 3. Okay, so this actually will become 2 1 times 2, constant becomes 0, and that's it. It's going to be 2 meter per second per second. Whenever we get a constant value for the acceleration, it means it's going to be stay the same for the two endpoints. What does it mean? It means acceleration at endpoint 0 is going to be equals to 2 meter per second because it doesn't change. It's constant. And value of the endpoint for 2 for acceleration is the same as well. So this was the first part, B part. In the C part, they said, when, if ever, during the interval, does the body change directions? Now we need to find out whether the direction is going to be changed at any point or not. Let's see how we do it. Okay, the C part. Now, in order to find the in order to find the directional, in order to identify whether the point, whether the body is changing direction during the movement or not, we actually let velocity equals to 0. So let's suppose velocity at time t equals to 0. Velocity was, remember, is 2t minus 3 equals to 0. Velocity here, and here we already found out 2t minus 3. So let it be equals to 0. Then we simplify it for the time. So time becomes equals to 3 by 2 seconds or 1.5 seconds. Okay, next. Let's suppose if this is our time interval, okay, this is our time interval, for example, and this is moving from 0 to 2 as given in the question. It's from 0 to 2. Okay, in this time interval, we need to see whether t equals to 3 by 2 is existing in between these 2 points or not. Yes, 1.5 is between 0 and 2. So 1.5 would be, is if 1 is over here, this should be 1.5 over here. So this is our time, 3/2 second here. Okay, we need to find the value of the function for the velocity before at any point and afterwards at any point, but before the endpoints, in between the endpoint sign. If they have the opposite signs, the body changing direction. If they don't have the opposite sign, body is not changing direction. What does it mean? Let's find out. So for the velocity, which we already said that is equals to 0, what if I take the velocity at, if this is my 3/2, before, what if I take the value as 2 before, and afterwards I can take any value. Let it be, if it was 1.5, let's take it here as 1.8. It should be in between the endpoints. So for 1, the velocity become equals to 0. So it's 2 into 1 minus 2 into 1 minus 3, which ultimately becomes 2 minus 3, which is minus 1 meter per second. Minus 1. Okay, so that's minus 1. What's important? Important is this became negative. Okay, this became negative here. All right, let's go for the second one. If we have this value as positive, only it is going to prove that this is the body is going to change direction. So velocity at time 1.8 in the function. So it equals to 2 into is 2t minus c. So 2 into t is 1.8 minus 3 equals to, let's find out, 1.8 is 3.6 times 2 minus 3 is going to be equals to 0.6. 0.6. So what's important? Important is this one is negative and this one is positive. It means somewhere the body changed direction. Direction changing switches the sign basically. So for this one, we get a positive value here for 1.8. As the signs are opposite, so it proves that the body changes direction at t equals 3/2. So the conclusion says the body changes direction at 3/2 second. That's our question number 1, A part, B part, and C part. Now for the question number 2. Okay, for question number 2, it says the same thing. We are given a function of the displacement and we're given a time interval 0 to 6, and we have to answer the same question again: displacement of the body, average velocity, and all the things we just mentioned been through in the first part. So let's work out the first part of the question, which says find the displacement and average velocity. So displacement. Okay, displacement. All right. For displacement, ds equals to the value of the displacement at the endpoint 6, the final endpoint 6 minus the initial endpoint, which is 0. So let's work out 6 into 6 minus 6 square, negative sign. It's 0. So it's going to be 6 into 0 minus 0 square. And we can see it's 36 minus 36 minus 6 into 0, 0, minus 0, anything raised to power equals to 0 itself. So it's going to be actually 0 meter. So displacement is 0 meter. Next, average velocity. To get average velocity, average velocity actually equals to total change in displacement divided by total change in time. Displacement is 0. The change in interval 0 to 6 is going to be 6 minus 0 equals to 0 over 6 and ultimately becomes 0 meter per second. If no change in displacement, if there is no displacement, it means there is no velocity, no change in displacement, so there's no velocity. So every velocity is 0 here. Okay, the second part says find the body speed and acceleration. Body speed. Okay, body speed. Speed, which already knew, that is equals to the absolute value of the velocity. Uh, so what's the velocity? Let's find the velocity first. Velocity equals to actually the first derivative of the function. If we find the first derivative of the function here, it's going to be 6t means 6 only, negative 2t. 6 minus 2t. 6 minus 2t becomes the first derivative of the function. Now we need to find the speed at the endpoints for this very function. So speed at the endpoint 0 equals to 6 minus 2 into 0 equals to 6 minus 0 equals to 6 meter per second. And speed at the endpoint 6 equals to, 0 to 6 or 6, 6 minus 2 into 6 equals to 6 minus 12 equals to minus 6 meter per second. 6 and minus 6 meter per second. Okay, acceleration. Acceleration is actually the first, second derivative of the function, or the we find the derivative of the velocity here. So acceleration equals to dv over dt equals to v over dt. Velocity is the function we just found out, 6 minus 2t, which ultimately becomes, so the constant becomes 0, and minus 2 becomes 6 minus 2, so it's going to be 0 minus 2 or just minus 2. So again, we had a constant value for the acceleration. What does it mean? It means acceleration at the endpoint 0 must be equals to minus 2 meter per second, and acceleration at the endpoint 6 equals to minus 2 meter per second. That's a theory for the constant values. All right. In the C part, again, we need to identify whether the body is going to change its direction at any point or not during the interval. So we let the velocity at time t equals to 0, which is actually 6 minus 2t equals to 0. And the value of t becomes equals to 2t, or t will become equals to 6 by 2, 3 seconds. Time is 3 seconds. And we need to find, now we need to see if this is existing with our given interval, which is 6, 0 to 6. 0 to 6, 3 mean is supposed to be in between here. Okay, we need to find the value before and afterwards. Before one, we just take some smooth value 2, and afterwards, let's take 4 and fill this into the velocities function and see if we get the opposite values. So velocity at 2 equals to 6 minus 2 into 2 equals to 6 minus 4, which is 2 meter per second. And velocity at 4 equals to 6 minus 2 into 4 equals to 6 minus 8 equals to minus 2 meter per second, which are opposite to each other. If they are opposite, the values are opposite in sign, positive, plus 2 and minus 2. So at 2 we got a positive value, and at 4 we got a negative value. When it happens, we actually term this as the body change direction. The body change direction at time equals to 3 seconds. Let's move to question number 3 with the same question answering. So in the first part, find the body's displacement, which equals to the displacement at the endpoint 3 minus displacement at the endpoint 0, which equals to minus 3 raised to power 3 plus 3 into 3 raised to power 2 minus 3 into 3. Let's move this a little. 4. Okay. Negative sign, bracket, okay, minus 0 raised to power 3 plus 3 times 0 perfect square minus 3 times 0 closed equals to minus 3 3 times 9 9 3 times 27 9 3 times 27 minus 9 minus uh, 0 0 and 0, so there is nothing left here, it's all 0. So now plus 27 minus 27 cancel out and we are left with only minus 9 meter. This is the value for the displacement. Okay, if this is the value of the displacement, what is acceleration? Average velocity. So what's the average velocity? Average velocity, average velocity equals to change in displacement divided by change in the time interval. Change in the displacement is minus 9, change in the time interval it's 3 minus 0, which ultimately becomes minus 9 over 3 r equals to minus 3 meter per second. That's the average velocity. The second part of the question said body speed and acceleration. Body speed, if you already knew, is absolute value of the velocity. So absolute value of the velocity. So we need to find the velocity first, which actually equals to the derivative of the function of the displacement. Okay, so equals to d s over dt and d as our function given here is minus t cubed plus 3t squared, 3t cubed minus t cubed plus 3t squared minus 3t. Okay, so let's find its derivative. So it's going to be minus 3t squared plus 60 and minus 3. So this is the value of the velocity, and we need to find its absolute value at the endpoints, which are 0 and 3. So velocity at 0 equals to minus 3 times 0 perfect square plus 6 times 0 minus 3. So we are left with minus 3 meter per second here. And for the velocity at point minus sign, yeah, we need to take the absolute value, so it would become positive. Okay, so velocity speed at point 3 equals to absolute value minus 3 into 3 perfect square plus 6 into 3 minus 3 absolute value. One little bit calculations. Let's do this on the calculator. So this will result in 12 meter per second. 12 meter per second. 3 meter per second and 12 meter per second. Okay, second part of the question said find the acceleration as well. And what's the acceleration? As we knew, acceleration is actually the rate of change of the velocity. Rate of change of the velocity, dv over dt. The velocity is minus 3t squared plus 6t minus 3. When we take its derivation, it's going to be minus 6t plus 6. Minus 6t plus 6. Okay, now let's find the acceleration at the endpoints. Acceleration at 0 minus 6 into 0 plus 6 equals to 6 meter per second. And acceleration at 3 equals to minus 6 into 3 plus 6 equals to minus 18 plus 6 equals to uh, minus 12 meter per second. Okay, we take this value which we already worked at for acceleration, and we substitute the value our inputs t as 0 and 3 one by one, and we find their values, and that was asking the question. Okay, that was our B part. C part says find that whether the body is going to change this direction or not, right? Okay, in order to find that, we say let the velocity at time t equals to 0. If velocity at time we let it be 0, which is minus 3t squared plus 6t minus 3 equals to 0. Let's take the 3 common out, or negative 3 common even. So it's going to be t squared minus 2t plus 1, everything equals to 0. We divide both sides by minus 3 and we got rid of it. So t squared minus 2t plus 1 equals to 0. It's a quadratic function. We can, or it's going to be the formula a plus b perfect square as well. So it's going to be t minus 1 perfect square equals to 0. So the value becomes we take the square root on either side, so t minus 1 equals to 0 then, or t become equals to 1. We don't do, of course, we do not select as negative 1 for the time because seconds cannot be negative. So it's going to be t equals to 1 second. Let's see if this is existing in our time interval or not. The time interval was 0 to 3. Yes, 0 to 3, yeah. So in our time interval, which is from 0 to 3, 1 is somewhere here, roughly. So we need to find value before 1 and after 1. Afterwards, I will choose 2, and before I will take 0.5, a smoother value. Let's see if they are positive or negative positive mean opposite values, which will be proving the body is changing its direction. So at point for the velocity, at point 0.5. So our speed is minus 3 into 0.5 perfect square plus 6 into 0.5 minus 3 equals to, your calculator, is going to be minus 3 by 4, which actually a positive value, a negative value, sorry. So this became negative here. Let's look at the right hand side, which is where we need to substitute velocity at point, add 2. Minus 3 into 2 perfect square plus 6 into 2 minus 3. Okay, this is again negative value, minus 3 meter per second. Again negative value. So on either side we got negative values. What does it mean? It means whatever the direction the body was moving with, it did not change its direction. So we say that the body never changed direction. Whatever the direction the body was moving with, it is still moving with the same direction. Question number 4. Body displacement and average velocity again. So for the displacement, ds equals to displacement at the end point 3 minus displacement at the end point 0 equals to raised to power 4. So 3 raised to power 4 divided by 4 minus 3 raised to power 3 plus 3 perfect square. Let me use the calculator please here. Row 3 by 4, everything t raised to power 4 divided by 4 minus 3 raised to power 3 plus 3 square. Let's calculate that together. Okay, so negative sign, bracket, and now it's for 0, so 0 raised to power 4 divided by 4 minus 0 raised to power 3 plus 0 raised to power square, so everything becomes 0 actually. Alright, so the final answer becomes 9 by 4 meter. 9 by 4 meter. That's the displacement. For the average velocity as it's equals to the change in the displacement over change in the time interval. Displacement we already had as 9 over 4, and the time interval change is 3 minus 0. 3 minus 0. So it will become 9 by 12, which will become 3 over 4 meter per second. Okay, that's one more thing we would keep mentioning second completely as it's required in our calculus here. So wherever I had second square, I hope you guys would switch it accordingly. Okay, so displacement average velocity. Now we need to find the speed and acceleration. In the B part, speed, which actually equals to the absolute value of the velocity at time t. So find the absolute value first, find the velocity first. Velocity is what? Velocity is actually the rate of change of displacement, which is d over dt. The displacement is d4 over 4 minus t raised to power 3 plus t square. Okay, so for t raised to power 3 over 4 minus 3 t square plus 2t. 4 cancel 4, so it's going to be finally written as t cube minus 3t square plus 2t. Okay, now we need to find these absolute values at the endpoints 0 and 3. So speed at point 0, absolute value, equals to 0 raised to power 3 minus 3 times 0 raised to power 2 plus 2 into 0, and ultimately becomes 0 meter per second. For absolute value at 3, confirm it's 3, yeah, it's 3, equals to 3 raised to power 3 minus 3 into 3 perfect square plus 2 into 3, and its absolute value. So let's do the calculator. 3 minus 3 into 3 is to power 2 plus 2 into 3. Okay, this gives us 6 meter per second. 6 meter per second. 0 meter per second and 6 meter per second are the values of the speed at the endpoint. Now for acceleration, as acceleration equals to the rate of change of the velocity. So change of the rate of change of velocity, and velocity is t cube minus 3t square plus 2t. Let's find its rate of change, so which is 3t square minus 6t plus 2. 3t square minus 6t and plus 2. Let's find the values of acceleration at the endpoint. So acceleration at endpoint 0 going to be equals 3 into 0 perfect square minus 6 into 0 plus 2 equals to 0, 0 and 2 meter per second square. and acceleration at 3 equals to, it's 3. So actually at 3 equals to 3 into 3 perfect square minus 6 into 3 plus 2 equals to 9 from, okay. So this is 11 meter per second square. Now for the next part of the question. This was our A part. Okay. Next part of the question, whether the body is changing its direction during the travel or not. C part. We let the velocity at time t equals to 0, and the velocity is actually tq minus 3t square plus 2t equals to 0. Let's take the t common out, so it's going to be t square minus 3t plus 2 equals to 0. We got rid of the t after dividing both sides by t. And then t square minus 3t plus 2. T square minus 3t plus 2, so it could be minus t minus 2t plus 2 equals to 0. T common from the first pair, 2 pairs, so t into t. Midterm breaking, minus 1 minus 2 into t minus 1, everything goes to 0. T minus 1 into t minus 2 equals to 0. So either t equals to 1 or t equals to 2. So there are two values of the time interval. It's more complicated, huh? So our time interval this time given as, okay, it is actually from between 0 to 3. 0 to 3. So let's put, if we have 0 here and 3 here, and maybe 1 here and 2 is over here. So we need to find the values before and afterwards of our time interval. So we need to find actually here 3 different values. Okay, for before one, let's find out for, let me choose 0.5 here, white color, 0.5, afterwards 1.5, afterwards 2.5. How's that? Okay, so velocity at 0.5 equals to 0.5. Remember, this is our velocity, so raised to power 3 minus 3 into 0.5 perfect square plus 2 times 0.5. Let me shift this a little. Okay. Okay. So 0.2 times t or 0.5. Okay, in short, if I say, if it's positive, okay, the value is positive, what about v at 1.5? V at 1.5, so switching 0.5, 1.5. Okay, 1.5 is going to be negative. And velocity at 2.5, it's positive. So let's see if it is actually going to help us any. So at 0.5 is positive, 1.5 negative, 2.5 positive. So we have a pattern of opposite values actually. When we have the pattern of opposite values, we say yes, the body is changing its direction. The body changes direction at time equals to 1 and time equals to 2. See you in the next video to complete the rest of the questions. Till then, bye.